Hi guys, welcome back. Hopefully you've made it through all of the trig units that we've had. And so what we decided to finish out this year, and also going forward, I could use these videos as review for next year as well, that what we're going to do is we're going to go back to something that you should be familiar with from Algebra 2, which is polynomial and rational functions. And so they're very important functions for calculus. And so we thought that we would spend the rest of the year kind of doing a good review of those. I'm not going to thoroughly do every note packet, but I am going to kind of do a kind of smattering of examples that they would have, and hopefully that will help you as you are working toward reviewing these for next year. All right, so our first video is going to be fairly easy and fairly short because it's really just on factoring, which you guys are amazing at. And so that's something that we want to just kind of do a quick recap of what we're looking at. So starting in here, and I'm just going to make sure my technology is all working here, that factoring is just undistributed. One thing that I do want you to remember is that the greatest common factor is the thing that needs to be pulled out first. Like you should always check for the GCF. The other thing that is just kind of as a common thing, if your lead coefficient is negative, you want to factor out the opposite of that greatest common factor. Pull the negative out. It makes it a little easier to deal with when the leading term is a positive term. All right, so if the term is a binomial, some common things that we're going to do is things like check to see if you've got a difference of two perfect squares. I'll do the first problem. I'll leave the rest for you to do. So here we have 2x cubed minus 32x. The first thing I'm going to say is that there is a GCF. My GCF is going to be 2x. So I do want to pull that out. And when you are factoring it out, remember you're just dividing it out. 2x cubed divided by 2x is going to leave us with x squared. And 32 divided by 2 is going to leave me with 16, and I pulled the x out. And you can see right there that I have the difference of perfect squares. So I have 2x, x plus 4, x minus 4. So all very easy things for us to take a look at. All right, I'll leave the rest of those in that section for you to do. Let's look at the next strategy. So in that one, it says if your polynomial is a binomial, check to see if it's the sum or difference of two perfect cubes. Now at this point, you may want to, I'm going to pause the video for a second. I want you guys to see if you can remember what the factoring forms are for the sum or difference of perfect cubes and add them in. So go ahead and you write them down on your paper. And I'm just going to count to 5 and then we will check. 1, 2, 3, 4, 5. All right, so taking a look at this, check yours. And obviously what's in the A and the B position can be a little bit more complicated than that. But that definitely is something we're going to look at. So like this first one, x cubed minus 27. That's the same as, I'll just put up here originally. So you're going to have your x cubed and then minus your 3 cubed. So it is the difference of perfect cubes. So our A is x, our B is 3. So we would do x minus 3 and then x squared plus 3x and then plus 9. Notice that if there is a minus here, there's always a plus in that location or vice versa. So, and like I said, and the big thing about looking at these, like let's look at the last one on this one. Notice that I've got the negative 3x to the fourth and the minus 192. So you do want to do GCF first, and we are going to pull the negative out. So I'm going to start by pulling out a minus 3x. So what's left would be x cubed and then plus because of the minus. And then we have to do 3 goes into 192. So I believe that would be 6 and 64. And so that gets us to there. And so what we're going to recognize is that our A is going to be x, and then 64 is 4 cubed. So now I'm ready to factor it. Let me just move over a little bit. So negative 3x, then we're going to have x plus 4, and then our x squared minus 4x plus 16. And so that kind of shows you our factoring for those. All right, let's take a look at the next section. All right, so in the next section, what you're looking at is if you have a trinomial, which basically just means that you have three terms, you're trying to factor it into a um, product of two binomials. Now, a lot of times we'll just use guess and check, especially if they're fairly limited options. So when I'm looking at this, like the 2x to the fourth, you know that the product of the first term in each one has to be 2x to the fourth. So you pretty much are going to be left with something along that line, the 2x squared and the x squared. Now we know that the terms that are at the last have to multiply to give us 20. So our options, of course, are 2 and 10, 1 and 20, 4 and 5. And so you kind of go through all the different options that you might have, and you try to guess and check which one is going to work, and you're trying to add up. Remember that when you multiply out the inner and the outer, I'll do those in green. So the inner and the outer, they have to add to this middle term right there. So as I kind of go through my different options, I'm going to go with the 4 and 5 because I know that 2 times 4 is 8. And 8 and 5, when you add them together, are going to be 13. And then because there's a plus here and a minus here, this would be a minus and that would be a minus. Now, the other thing is when you're looking at this is not completely factored. It's going to be able to be factored a little bit more. So let me move these out of the way. I'll just stick them over there so that I can continue going down. Oops, undo. All right, and so down here, now 2x squared minus 5, it's not a perfect square. It's not the difference of perfect squares. This is what we consider to be a prime factor. So we're just going to leave that one as is. Now we could factor it into nice form. It has like radicals in it and things, but we usually don't when we get to this point. The x squared minus 4, though, definitely can be factored x plus 2, x minus 2 as we're looking at it. Now, there are other options, other techniques for factoring that you would have available to you. There's the box method. I'll do the box method for this one over here on the side, just to kind of show you what it looks like. The box method, I would have taken 2x to the fourth and the 20, and you're going to multiply this out. So this is going to end up equaling, let me make sure I'm on the screen, equaling 40x to the fourth. Then you're going to split this into two factors that are going to add to the negative 13. So negative 13x squared. Now, obviously, we need an x squared and we need an x squared. Factors of 40 are 8 and 5. So 8 and 5. And then they both need to be negative in order to add to the negative 13. Oops, sorry. Let me slide over for you here so you can see what I'm doing. Now you take these two items here and you're going to fill them into the alternate areas in your box. So negative 8x squared and negative 5x squared. And then what you basically are going to do is you're going to get the GCF of each row and column. So in the first row, I can pull out an x squared. In the bottom row, I can pull out, and if it's a negative, you always pull it out. So it's negative and 4. And notice there's the x squared minus 4 from the factor over there. And then you do each column. In this column, I can pull out a 2x squared, and then I can pull out a negative 5. And then there's the other factor that was in our factoring form. All right, so that's that one. Now let's go ahead and let's look at our next item, which is factoring by grouping. So let's come down here to our example and we'll do that as. All right, factoring by grouping, order your terms from greatest to least degree. That's going to be kind of the key to doing this. Then what you're doing is you're grouping the first two terms and the last two terms together. Or if it's an even number, if there were 6 terms, you would group the first 3, group the last 3. So you're going to look for your GCF. And so the GCF of the first term is just x squared. And then we have 2x plus 3 that's left. And then over here, this minus 8x minus 12. I'm going to pull out the negative, right? So minus. And I can pull out a 4. And that's going to leave me with 2x. And if this works well, hopefully you'll see that you have exactly the same factor in those two locations. And so with our factoring by grouping, then you basically considered what's turquoise there as a GCF. And now I am going to pull that GCF out, 2x plus 3, and what you're left with is x squared minus 4. And then from there, and I like to put equals here and here, check to see if there's anything else that factors at that point. I have that x squared minus 4, so 2x plus 3, x plus 4, x minus 4, and we're done with that one. All right, I'm going to leave the next one for you, and there are several down here that you can see for extra practice. I'll put a key up to this so that you can double check. All right, so now what we're going to do is we're going to come down to making this connection between the factors and the graphs. Okay, so taking a look at this polynomial f of x, the first thing that you should notice is that it really needs to have a GCF pulled out. So I'm going to start with my factoring process, and we'll just come over here. We're going to pull out a 3 and an x. And when I pull out that 3 and the x, I'm going to be left with x squared, then plus 4x, and then plus 4. So that gets us to that part. Now we're not completely done. We want to keep going until we have factored this completely. So bring down your 3x. I'm just going to do a guess and check. So we have x and x, and then the middle term, 2 and 2, and then plus and plus. So I'm going to rewrite this in its nicer form, x plus 2 squared. And so there's a lot of things that we're going to take a look at kind of as we go through this. Now, once we factored it, it says set each factor equal to 0 and find the values of x. So we're basically taking our polynomial, and when we set each factor equal to 0, we're setting the entire polynomial equal to 0. And then what we're using is the zero product property, which says that if the entire polynomial is set equal to 0, then we can set each factor equal to 0. Now, obviously, so you have 3x equals 0. Technically, it's x plus 2 equals 0, x plus 2 equals 0. But we never really write it the second time because we pretty much know that that is going to be the same answer. So it equals 0 at x equal to 0 and x equal to negative 2. Now, this does tell you something, the fact that this occurred twice. This is what's called a double zero or a double root, and that's something that hopefully rings a few bells in you. Now, looking over here at our graph, you can see right here that there is an x-intercept here of negative 2, 0. And also, do you see how this bounces as it goes up through there? So if I'm looking at this thing right here, that you can see that it comes up, it bounces, and it comes back down. And then the same thing over here. Do you see how this one, it was just a single 0, right? It only occurred once in the problem, and that single 0 just crosses. And so that's something we're going to talk about in more detail later, which is called the multiplicity of the zeros and the behavior of the graph. So first, we see that we get x-intercepts from setting these factors equal to 0. Now, the other thing to look at would be the y-intercept. All right, the y-intercept of this graph right here, that's the x-intercept and the y-intercept. It is 0. And notice that the constant term, that there wasn't one back in that general form, and that constant term was 0. And so that's something to notice. All right, so what I would like you to do at this point is go ahead and pause the video, and I would like you to work the remaining problems on this page and the next page, and then answer the question about what connections that you see between the polynomial and the graphs of the functions, and then come back to the video. So go ahead and hit pause and then come back. All right, so summing up this packet of notes, check your answers with the key. In the general form, put your terms in order from greatest power to smallest. The degree is the greatest power. The lead coefficient is the coefficient of the beginning of the highest power. The constant is your y-intercept. Your factors set equal to 0 give you your x-intercepts. Those are called zeros, and the maximum number is the number of the degree that's there. Go ahead, complete the homework for this, do the worksheet, check your answers, and come